Hey guys, welcome back to the CAIE Lab. In today's video, we're continuing our chapter on carboxylic acids, which seem difficult at first, but once you understand the main concept, it becomes much more easier. So let's get started. Carboxylic acids are the derivative of hydrocarbons because they contain another element other than carbon and hydrogen. Other than that, carboxylic acids are the saturated compounds because they contain a single bond between the carbon and carbon atom. And they have a general formula of CnH2n plus 1 COOH, where this COOH is our carboxyl group. And in the displayed form, it's written like this, where C is double bonded with O and single bonded with OH. Now, one thing you must remember is that N usually represents the total number of carbon atoms. But in the carboxylic acids, we always take N as one less. Why? Because one carbon atom is already present in the COOH functional group. Let's take an example of methanoic acid where is only one carbon atom present. But that carbon atom is already inside the COOH group, and therefore we replace that N with 0 in the general formula. And that's how the formula is satisfied. Now, carboxylic acids are also named, and their name ends with oic acid, just like we have methanoic acid, ethanoic acid, and propanoic acid. Now here's a whole series of carboxylic acid compounds along with their name and their molecular formula. It's more preferable for you to memorize it so you're instantly able to figure out the organic compounds in your exams. Now let me show you how to write down the molecular formula of the carboxylic acids using their general formula. So the general formula of carboxylic acids is CnH2n plus 1 COOH. And N is taken as 1 less, so we're going to write C0, H2 multiplied by 0 plus 1 COOH, and we get 8 COOH as our molecular formula for methanoic acid. Now to write down the displayed structure formula, firstly, draw your carboxyl group like this, and then complete the 4 bonds of this carbon atom. 3 bonds of it is already made, so let's complete the rest 1. And as you know that there is no other carbon atom in the methanoic acid, so we're just going to put an H atom to complete our displayed structure formula. Now to write the condensed structure formula, we just have to write the molecular formula as it is because there is no other carbon atom to be separated. Now let's take an example of ethanoic acid. Here N will be represented as 1, so we're going to write C1 H2 multiplied by 1 plus 1 COOH. And we're going to get CH3COOH as our molecular formula. Now to write down the displayed structural formula, firstly write down your carboxyl group like this, and then complete the 4 bonds of this carbon atom. Now you know that there are 2 carbon atoms in the ethanoic acid, so let's write down the second carbon atom, and then complete the rest bond of this carbon atom. 1 bond of it is already made, so let's complete the rest 3, and then put H atom along with each line. And this is how we have written the displayed structural formula of ethanoic acid. Now to write down the condensed structural formula, we're just going to separate both of these carbon atoms. Here CH3 is written at the left side, so we're going to write CH3, and then write down your carboxyl group as it is, as COOH. And this is how we have written the condensed structural formula of ethanoic acid. The same thing is going to happen with butanoic acid. The molecular formula of it is C3H7COOH, and the displayed structural formula is like this. Now, take a moment on your own to solve this example. Pause the video right now, and when you're ready, resume it to see the solution. Alright, so now let's solve it together. We have propanoic acid as our example. Firstly, let's write down the molecular formula of it using the general formula, which is CnH2n plus 1 COOH. Here, N is going to be represented as 2, so it's going to be like C2H2 multiplied by 2 plus 1 COOH. And our molecular formula is going to be C2H5 COOH. Alright, so now let's write down the displayed structural formula of propanoic acid. Firstly, draw your carboxyl group like this, C double bonded with O, and then single bonded with OH. And now you have to complete the 4 bonds of this carbon atom. So 3 bonds of it is already made, so let's complete the rest 1 like this. And now you know that in propanoic acid there are 3 carbon atoms, so let's write down the rest 2 like this, and we're going to join both of these C's together with a single bond. And now let's complete the 4 bonds of each C. It has 2 bonds of it is already made, so let's complete the rest 2. And we're going to do the same thing with this. And now let's put H atom along with each line like this. 1, 2, 3, 4, 5. And this is how we have written the displayed structural formula of propanoic acid. Now let's talk about the condensed structural formula. We have to separate the 3 C's. So firstly, we have CH3 at the left side. So we're going to write CH3 here. And then we have 1 CH2 to write. So we're going to write CH2. And then we have our carboxyl group to just write down as it is. So it's going to be like COOH. And this is how we have written down the condensed structural formula of propanoic acid. Now, another thing to focus upon is the preparation of carboxylic acids. This whole process we just have read in detail in my previous video. This process is called the oxidation of alcohol, where alcohol reacts with the atomized oxygen in the presence of acidified potassium permanganate, which acts as an oxidizing agent to form carboxylic acid and water. Here, ethanol reacts with the atomized oxygen to form ethanoic acid and water, and the same thing is happening with butanol and heptanol. Now let's talk about the physical properties of carboxylic acid. The first property is that they are sour in taste, just like vinegar and citrus fruit, and they're corrosive in nature, meaning they can damage metal and burn the skin, and they turn blue litmus paper red. Litmus paper is actually an indicator that helps us to distinguish between acid and bases. Carboxylic acids are also soluble in water, and they conduct electricity in their aqueous solution form. Now let's talk about the chemical properties of carboxylic acids. In total, there are 4 chemical properties. We're going to study the whole thing in detail in a later chapter, but for now, let's cover them briefly. The first chemical property is the reaction of carboxylic acid with bases. Here, ethanoic acid reacts with sodium hydroxide to form a salt of sodium ethanoate and water. Here, the Na is replaced with the H to form this sodium ethanoate. Let me show you how to form this compound. So here we have the ion of ethanoate and we have an ion of sodium. The charge on the sodium ion is positive, 1 positive, and the charge on the ethanoate ion is 1 negative. And we have to exchange the charges. The charge of the sodium ion goes to the ethanoate ion, and the charge of ethanoate ion goes to the sodium ion. And this is how our compound forms, which is CH3COONA, and it's called sodium ethanoate. Now, another example here is of propanoic acid, which reacts with magnesium oxide to form magnesium propanoate along with water. Now, magnesium propanoate is formed when the magnesium is replaced by the hydrogen in the propanoic acid. Now, here we have 2 ions. The first one is of propanoate with a -1 charge, and the second one is our magnesium ion with a 2 positive charge. Now, the charges are exchanged. 2 comes here and -1 goes here. So we get C2H5COO bracket 2 Mg as our product, which is the molecular formula of magnesium propanoate. Now you can see that there is no 1 written here because it's not mandatory to write or do not write the 1. The second chemical property of carboxylic acid is the reaction of carboxylic acid with the metal carbonate to form salt, water, and carbon dioxide. The third chemical property of carboxylic acid is the reaction of it with metal to form salt and hydrogen gas. Now, the fourth chemical property of carboxylic acid is the esterification. It is the process which forms the esters. Esters are the pleasant-smelling compounds which are used in the industrial products such as artificial food flavoring and the perfumes, etc. Esters are formed with carboxylic acid reacts with alcohol. Here we have carboxylic acid when it reacts with alcohol in the presence of concentrated sulfuric acid H2SO4. we get ester and water as our product. And you must remember, whenever the examiner asks about the catalyst for the esterification, you must write concentrated sulfuric acid. Now, let me tell you in depth how to form esters. We have here the displayed structural formula of butanoic acid, and here we have the displayed structural formula of propanol. And firstly, the OH from the butanoic acid is taken, and the hydrogen H is taken from propanol, and both of them are reacted together to form water. And now, as you can see, that O is only bonded from one side and not the other. And here carbon is bonded from three sides and not the fourth. And therefore, to complete the bond of each atom, we revert this whole propanol side and attach it with the butanoic acid side. And the ester formed is called propyl butanoate. And here you can see that in between the displayed structural formula of ester, we have a C double bonded with O and a C single bonded with O. This thing is called the ester linkage, and this is the thing that is used to identify the esters. Now, let me tell you how to name the esters. So the first part comes from the alcohol side, and the second part comes from the acid side. So whenever you're taking the first part from the alcohol, you remove that old thing and you replace it with ol. So it's propyl, not propanol. And with the acid, the same thing has happened. So we remove the oic thing and replace with OH. So it's not butanoic, it is butanoate. So the name of the ester is propyl butanoate. Alright, so now let's talk about the uses of esters. Esters are used in making artificial food flavors, and they're also used as solvents for various organic compounds. And due to their pleasant smells, they're also used in making perfumes. Now let's talk about the example number 1, which is of propyl ethanoate. In this reaction, ethanoic acid reacts with propanol to form propyl ethanoate and water. And these are the molecular formulas for the all compounds acting in the reaction. And this is the reaction in the displayed structural form. Now let's talk about the example number 2. Take a moment on your own to solve this example. Pause the video right now, and when you're ready, resume it to see the solution. Alright, so now let's solve it together. Firstly, let's write down the molecular formula of each compound. We have butanoic acid first, so let's write down its general formula, which is CN H2N plus 1 COOH. N is taken as 1 less, so we're going to write C3 H2 multiplied by 3 plus 1 COOH. And so the molecular formula is C3 H7 COOH. Now, let's talk about the ethanol. Its general formula is CN H2N plus 1 OH. Here, eth means 2, so we're going to replace N with 2. It's going to become C2 H2 multiplied by 2 plus 1 OH. And we're going to get C2 H5 OH. Now, we're going to first draw the displayed structural formula of the ester, and after that, we're going to write the molecular formula of it. So let me show you how to do that. Firstly, write down the displayed structural formula of the butanoic acid. We're going to first draw our carboxyl group like this. C double bonded with O and then single bonded with OH. And now we have 3 carbon atoms to be written. So we're going to write 3 carbon atoms. And we're going to join each of carbon atom together with a single bond. And then we're going to complete the bond of each carbon atom. This has 2 bonds of it already made, so let's complete the rest too, like this. And the same thing is happening with this, and the same thing is happening with this. Now let's put H atom along with each line, like this. Second, third, fourth, fifth, sixth, and seventh. Now let's write down the displayed structural formula of ethanol. Firstly, let's draw our C's. We have 2 C's in total. Then let's join our OH with the very last C and then complete the bond of each C. it has 2 bonds of it overridden, so let's complete the rest too. And the same is happening with this. Now let's put H along with each line, like this. And we have written the displayed structural formula of ethanol. Now we have to take OH from this side and H from this side, and we're going to join it together to form water. So it's going to be H2O. And we're going to revert this whole displayed formula and attach it with this acid part. So we're going to do it like this. Firstly, let's draw the acid part, which is with 4 carbon atoms like this. Double bonded with O. Now let's draw the ester linkage by joining it with the O of the alcohol part. And now let's complete the alcohol part with 2 carbon atoms. And now let's complete the bond of each carbon atom. Like this. 1, 2, and 2, 1, 2, 1, 2, and 3. And now let's put H element across, like along with each one. Like this. And this. We're going to do the same thing with the alcohol part. And this how we have drawn the displayed structural formula of our ester. Now it's time to name our ester. Firstly, let's see our alcohol part. We have ethanol here. We're going to remove this O from here, and we're going to write "-ile" instead of it, so it's going to become ethyl. And we're going to do the same thing with butanoic acid. We're going to remove this oic part, and we're going to replace it with OH, so it's going to become butanoate. And first part is from the alcohol, so it's going to be ethyl. And the second part comes from the alcohol side, so it's going to become ethyl butanoate. So the name of the ester is ethyl butanoate. Now let's talk about the molecular formula. Firstly, let's count the carbon atoms that we have here. We have 3 carbon atoms from this side. We're going to write C3. And then we have how many H? We have 1, 2, 3, 4, 5, 6, 7, 8. So we're going to write C3H7. And then we have to write this ester linkage like this, COO. And then it's time for this part. It's C2. And then we have how many H? We have 1, 2, 3, 4, 5. So we're going to write C2H5. And this how we have written down the molecular formula of our esters. So this was all for today. I hope you liked my video and understood the concept. Don't forget to hit the bell icon and subscribe to my channel. Let's meet in another video.